Now we had an equation excuse me, of a surface, z equals square root of 3 over 2x. It's a plane, and the xz plane cross-section looks like this. Profile looks like this, and it doesn't change in the y direction. Okay, so what we have then, if we want to find the area above a region of the xy plane, it turns out that, and we'll see that in a minute, but all we need to do is find the ratio between delta x down here along the x direction and the length of this segment here directly above it. Okay, well, the equation z equals square root of 3 over 2x, meaning the slope of this segment is the square root of 3 over 2, and it's a very short argument to see that the length of this segment has to be the square root of 7 over 4, or the square root of 7 divided by 2 times the length of this segment. And that's very, very straightforward if we understand what slope is and what that tells us about this triangle here. Because this distance is your delta x distance down here, and this is the distance we're trying to find, and we know the slope, meaning that this distance has to be square root of 3 over 2 times this distance, because the slope is rise divided by run. The rise has to be square root of 3 over 2 times the run. And the ratio then of the length of the segment to the length here is 1 plus the square of the square root of 3 over 2. We can see that in a number of ways. If we had 1 unit in this direction and square root of 3 over 2, square root of 3 over 2 units in this direction, then our hypotenuse would be the square root of 1 squared plus the square root of 3 over 2 quantity squared. In general, if we have 1 unit here and m units here, the slope is m, just as the slope here is square root of 3 over 2 divided by 1. The slope here is m divided by 1, which is just m. And the hypotenuse then, by the Pythagorean theorem, is the square root of 1 plus m squared. Okay? In this case, the ratio of this side to this side is this square root divided by this, and this square root comes out to be the square root of 7/4, or the square root of 7 over 2. So that this is the square root of 7 divided by 2 times this. So if this is delta x, this is the square root of 7 divided by 2 times delta x. In general, it's the square root of 1 plus m squared divided by 1 multiplied by delta x. Now we conclude, since if you have a region in the xy plane, okay, rectangular region, like so, and x is in this direction, z is in this direction, your surface, your plane is in this direction, and y, the value of z doesn't change as you move in the y direction. Okay, so if we have a delta x by delta y region, the area, the region on the plane up here, is a small rectangle in the direction of the plane. So if we have a small increment delta x, that's our delta x here, then on the plane, the corresponding edge of our region on the plane is going to have length square root of 7 divided by 2, or square root of 7/4, times the delta x down here. The delta y is going to be the same up here as it is down here, and our area is going to be the square root of 7 over 2 times the area of our delta x by delta y region. So that the region up here is has the square root of 7 over 2 times the area of the region down here. The area of the region down here being delta x times delta y. Okay. Now we ask, okay, that applies to any small region of the plane. Okay, any delta x by delta y region. Now it turns out that since the whole surface is a plane, this actually applies to the entire surface. But we can think of the fact that every small increment delta x by delta y of area down in the xy plane has above it a rectangle with dimensions delta y by square root of 7 over 2 delta x, and has then this region. So the areas down here have a multiplier of square root of 7 over 2. So the area above any delta x by delta y is this, as we've already said. Well, that is going to apply to the entire triangle, because the area of every small region down here, and when I'm talking about the triangle, I'm talking about the triangle that goes from 0, 0 to 1 half, to 1, I'm sorry, 0, 0 to 0, 1 to 1, 0. That triangle down in the plane is half of a 1 by 1 rectangle. It has area 1/2, or you can use a formula for the area of a triangle, but it should be unnecessary. That area being 1/2, then we just multiply this multiplier, square root of 7 over 2, by the entire 1/2, since the same multiplier works for every little area increment down in the plane, and we get the area above the triangle. And this should all be really pretty obvious. Now, we move on to something that's a little bit less obvious. But this whole analysis, all these results should be obvious, and you need to think through the situation to make sure that it's so.